A very good morning to you all. Today I am going to discuss about static balancing. Okay, here what the main objective of static balancing is, if you don't know the magnitude of masses, so with the help of this operating procedure we can able to make it balance in angular mode as well as linear mode. That is our main aim of this experiment. So here we are having three unknown masses. I don't know the magnitude of these three masses A, B, C, okay, but I can able to make it balance in linear mode as well as angular mode with using this procedure. Here I don't know the masses of magnitude of these three masses, but I can make it in a linear mode balancing as well as angular mode balancing with using this procedure. Here how I am going to balance these three masses with using this static balancing experiment means, see here I am taking three masses, okay, first mass is A and second mass is B and third mass is C. So I don't know the magnitude of this mass, but I can find this angular position as well as linear position. See here, this is a tabular column for this experiment. With using this tabular column, I am going to balance the masses in angular mode as well as linear mode. Here, first column represents serial number, second column represents the indication I'm going to give for three masses. First mass plane as A, second mass plane as B, third mass plane as C. Those things I represented in this column, and number of balls, steel balls, what we did in the experiment. So there, how we did, A mass is how many number of balls are weighing to lift the mass from 90 degrees to 0 position, means horizontal position. So accordingly, right side chamber, if I keep the balls, 40 balls, the mass is lifted from 0 to 90 degrees. Similarly, for B mass is 50 and for C mass is 56 balls are weighing. So similarly, left side chamber. So why we need to do right side and left side means for avoiding the flaws. So we are taking right side and left side how much of balls to weighing of that particular mass, so that we are going to consider right side as well as left side. Average of that we can avoid that kind of errors. So for that sake we are doing the this procedure to pour the balls in the left side chamber as well as right side chamber to weighing that mass. So here if we know the mass of the ball, we can find the total mass of the A block, B block and C block. If you don't know the ball, if you don't know the mass of the balls also, we can do the angular balancing as well as linear balancing. So this is the procedure here. So according to getting data, so 40 balls are consumed for A block and B block is 50 balls and C block is 56 balls on right side chamber. Left side chamber 38, 54 and 50. When I am taking the average for A block, 40 plus 38 by 2 it becomes 39. Similarly 50 plus 54 it becomes 52 average, and 56 plus 50 by 2 it becomes 53. So with the help of this column or with the help of this number of balls, easily we can find static balancing in angular mode as well as linear mode. Or if you know the ball numbers, ball mass, okay, we can find the total mass of the A block and B block and C block while multiplying with mass value of that ball, particular ball into this average number of balls. So with the help of that we can get the 40.6 grams for A block and 72.8 grams for B block, 81.2 grams for C block. So how much of lift we done here? 90 degrees. Why we are going to done? Why we done that 90 degrees? We'll see in our experiment already. Now, so for static balancing in planar mode or planar position, so equidistance if you keep the masses, okay, equidistance if you keep the masses linearly, so the all masses are due to gravity, it passing downward direction, so that it is balanced in linear position or plane position. But when we are balancing in angular mode, we need to do some exercise here. We need to construct a force diagram. With the help of force diagram only, we are going to balance the masses in angular mode. Here, first mass is initially I am assuming horizontal. With reference to A mass, I am going to balance the B mass and C mass. How I am going to balance the A mass and B mass and C mass? With the help of this force diagram, we can see now. Here, from the tabular column, A mass is 39 balls. So whether we can use fourth column data or third column data. So third column data means average number of balls oriented. Also we can able to find the angular position for three given masses. Okay. So here I am going to consider number of balls third column and the third C column. With the help of that, I am going to construct the force diagram here. Here scale I am going to take here, scale as 10 balls as 1 centimeter I am going to consider. So when I am considering 10 balls is 1 centimeter, the force means in terms of balls, I am going to consider the force of means the weight of the A block and weight of the B block and weight of the C block in terms of balls. So when we are considering of that, A block weight is that is equal to 39 balls in terms of scale, okay, 3.9 centimeters, and B block is 52 balls. When we are considering in terms of scale 5.2 centimeters, when we are considering C block, okay, in terms of balls 53 balls, then in terms of scale is 5.3 centimeters. I know the values of FA, FB, FC means weight of A block, weight of B block and weight of C block in terms of scale. Now with the help of these scalar values, I am going to construct force diagram. So what we are assuming in the angular position, okay, reference mass as A mass is horizontal we are considering, right? So that the force also acting horizontally we are assuming. So that's the reason here I am going to construct the vector AB. Vector AB represents weight of the A mass. Okay, vector BC represents weight of the B mass, and vector CD or CA represents given third C weight. So once if you consider A bar, AB bar, BC bar and CA bar, I am going to construct the force diagram. So initially I am going to draw horizontal line with the dimensions of 3.9 centimeters horizontal line. Why I am going to construct horizontal line means in our angular position initially we are assuming A mass as horizontal. So that's the reason I am going to draw this force value means vector AB as horizontal. After constructing AB, we know that force polygon or force diagram, force polygon tens, it's a closed loop. How many forces we are having? 3 forces or 3 weights we are having. So that all forces are interlinked to each other. That's the reason here after completing of AB vector, next vector starts at the end of the first vector. Here FA vector starting point as A, ending point as B. So according to polygon definition, then BC vector starts at B point. I know that point. And also I know it's a closed loop. It means that end of the third vector is coincide with the first vector starting point. So that I know the third vector starting point, ending point as A, second vector starting point as B. So what is the concept we know here? According to polygons, okay, it's a closed loop. All 3 vectors are interlinked to each other, so that after completing AB vector, BC vector start. After completing BC vector, CD vector or CA vector is starts. So here AB vector, after completing AB vector, BC vector starts at B point. I know the magnitude of BC vector. The BC vector magnitude is 5.2 centimeters. But I don't know the direction as well as I don't know the angular position. So, but I know the starting point of BC vector as B. But I know the ending point of CA or CD vector as A. So from this concept, I am going to construct with using engineering drawing basics. So with using compass, I am going to take 5.2 centimeters as a radius and B point as a center, draw the arc. How much of radius I am going to take here? 5.2 centimeters radius I am going to take. Why I am taking 5.2 centimeters means on this locus, the vector position is lies, the vector is lies, okay. So the vector BC is lies on this locus. So I need to find the angular position. I don't know what's the angular position exactly, but I know the concept of polygon. From that I am going to find the angular position. How I am going to find? I know the third vector mass, but I don't know the third vector angular position. But from the concept of polygon, okay, end of the CA vector as A point. I know the magnitude of a CA vector, that is 5.3. So ending point of CA vector as A. So A as a center, which using compass, 5.3 centimeters as a radius. I am going to draw a arc. Where that arc intersects, for first arc, mark it as B point. Mark it as B point. Then draw a line from B to C point. B to C point. This vector represents, okay, FB, or we can say CB bar. CB bar towards the C, right? That's why CB bar we need to indicate for vector formation. Now when I'm joining a C to A line, it represents third vector angular position. Third vector angular position, that is FC or AC vector. AC vector. AC vector, right. Now we need to find angular position, how much of phi and how much of theta. How we are going to find the angular position? See here, when I am extending off this AB vector, from the positive axis of x only we need to consider what's the angle of BC vector or CB vector. This is what we are assuming there, theta. So theta. So this is the angle we need to construct in the angular position of this angular position of position diagram. So this is the B vector diagram, or B mass or B weight angular position. Similarly, when I want to find the CD or AC vector or FC angular position with respect to initial position, means horizontal position. So this is the positive x-axis. What we are assuming, this one is A vector is in positive x-axis. That's the region you need to construct positive x-axis. From that, how much of angle it is, it consists that angle as phi. That angle as phi. So with an angle of phi, I am going to construct a C vector. This is the angular position of given masses without knowing the magnitude of masses. This is the static balancing procedure to find the angular position and linear positions of the three unknown masses with using this experiment. Guys, when we are going to experimental question, here this is the static and dynamic balancing mission. Here first of all we are going to solve our unknown masses for angular position and linear position, static balancing. So for that sake, what are the operators we require is this structure. This is the static balancing mission. Okay, and we require unknown masses. These are the three unknown masses I'm going to take, and one LNT I'm going to take, and some steel balls I'm going to consider. So this is the right side chamber, this is the left side chamber, and this is the right side chamber for pouring the balls in, and this is the reading scale for measuring of angular position of our unknown masses, how much of rotation takes place. So these are the things we require for finding static balancing. Now, when we are going to consider this experimental procedure, so we choose L and T, we need to type this mass in vertical position. At center of the shaft. This is the shaft. Okay, this is the shaft. So this is the element, bar element. So both the ends with the help of bearing supports, it rotates. Okay, one end of the shaft we are having a measuring scale. If the shaft rotates, this scale also rotates. So here, this is the pointer. With the help of this pointer, how much of rotation takes place by the mass while adding the balls on the chamber. This is the procedure we are going to cross-check. So initially what we have to do, so the 0 point coincides with the pointer, like that you need to keep the mass in 90 degrees at the center of the shaft. Now after assembling of that mass at the center of the shaft, okay, vertically, then you need to do some procedure, pouring the balls at left side chamber up to the mass reaches the horizontal position. How you can conclude the mass is in horizontal position is, so initially what's the position of mass? That mass is vertically downward direction, and the angular position with respect to the scale, okay, the shaft position is 0. When we are pouring the balls on right side chamber or left side chamber, when I pour the balls on right side chamber, so when I pour the balls on right side chamber, see, when I pour the balls, you can observe the mass is rotating towards the leftward direction. And also we can observe how much of angular displacement or angular rotation which takes place by the mass from this scale. So up to 90 degrees of angular position, we need to pour the balls. At 270 degrees, the indicator shows. It means that 90 degrees the mass is rotates. You can observe the mass from vertical position to horizontal position. Why we need to rotate the mass from 0 to 90 degrees means, when we are going to consider mass, unknown mass as stick. Okay, the unknown mass is stick. So with the help of my two fingers, I am holding this stick in different positions. So when I am keeping the stick in this manner, I may feel some difficulty. When I am keeping the stick in this manner, I may have more difficulty. When I am keeping the stick in this position, I may feel somewhat little difficulty compared to horizontal position. Why it consists such kind of feeling is, here moment definition oriented, we can say force into perpendicular distance is goes on, increases, moment also goes on, increases. Okay, so why? Because distance is proportional to turning moment, or distance proportional to bending moment. So here turning moment is the criteria, so that when I am keeping in horizontal mode, the center of gravity of this stick lies here and my finger's position is here. The perpendicular distance is more compared to this position as well as this position. See, you can observe. When I keep it in this manner, the perpendicular distance from center of gravity, here center of gravity is perpendicular to this direction is less. So that is that here turning moment, trying to move downward direction due to gravity is less compared to horizontal position. That is that we are going to lift the mass from 90 degrees to 0 degrees. 90 degrees to 0 degrees in this experiment. So initially we are keeping vertical 90 degrees, we are rotating while adding the balls on right side chamber and left side chamber. In this manner, we are going to repeat all masses. Okay, so you need to find number of balls are weighing for each and every mass, pouring the balls on right side chamber as well as left side chamber. You need to find how many number of balls for A block, B block and C block. So from that data, we are going to tabulate one tabular column, and with the help of that tabular column, we are going to solve of our unknown factors.